We are now seeing tens of trillions of tokens processed every month. This computational scale is the baseline for modern production AI, driven by automated agents performing multi-step workflows. This volume is a result of collapsing costs. A model with the intelligence of GPT-4 is now 50 times cheaper to query than it was 2 years ago. This chart tracks API tool calling reliability over the last 18 months. It has moved from an 85% success rate up to 99.5%, the threshold required for reliable production automation. While zero-shot non-agentic token usage has remained flat, agentic workloads are seeing exponential growth. An average agentic session now runs for 80 continuous turns of logic, executing tools and evaluating its own output without human intervention. These long horizon sessions saturate million-token context windows, allowing models to hold entire codebases in memory to solve complex engineering tasks. Autonomous agents have transitioned from experimental prototypes to the primary driver of inference volume in the market. The early promise of AI engineering was the lights-off software factory, a system where humans hand over tickets and agents return finished code. But removing the natural friction of human engineering time also bypasses the design review phase. This visualization shows the result of frictionless generation. A healthy codebase quickly develops architectural rot and duplicative logic as agents ship isolated fixes without system-wide context. Without constraints, agents default to horizontal hacks, bypassing design gates to force solutions into the easiest available layer. Teams using this workflow frequently encounter 1,200-line pull requests. These contain redundant logic that humans must eventually untangle by hand. Elite engineering teams are now moving away from this methodology, reinserting strict human checkpoints into the development loop. Unconstrained AI generation spills technical debt faster than it scales features. Managing agentic quality requires respecting the central constraint of frontier models, the instruction budget. This tracks context attention. While a model follows short directives, its attention begins to fail when pushed past 150 discrete instructions. When overloaded with system rules and task parameters, the model ignores instructions and begins hallucinating logic. The zero-shot megaprompt is an architectural anti-pattern. Complex engineering cannot be condensed into a single context window. Tasks must be broken into strictly bounded subtasks. Reducing instruction load per inference call ensures the model adheres to your system rules. Reliable AI behavior means engineering around its cognitive limits. The foundational rule of agent architecture is to use traditional code for control flow whenever possible. Rigid switch statements route data more accurately than LLM prompts, directing specific tasks to specialized subroutines. We replace the monolithic prompt with the QRSPI pipeline: questions, research, structure, plan, and implement. These stages are connected by deterministic code pathways. The agent generates clarifying questions, passed to a research module, informing design and structure phases. Before writing code, the agent outlines its intended architecture. This document is the specific point where a human engineer aligns the agent's logic with the broader system. You cannot train a model on good architecture with reinforcement learning. The cost of bad architecture is measured in months of technical debt. Predictable AI behavior is achieved through deterministic pipeline scaffolding, not better prompting. Deploying AI-generated code requires an automated verification layer within the CI/CD pipeline. Generative coding agents are optimized for speed and autocomplete, which can compromise long-term robustness. To defend the codebase, teams must deploy independent verification layers. This adversarial agent acts as a gatekeeper. Its sole directive is to find flaws in the incoming pull request. The adversarial layer references a centralized context plane containing your organization's specific linters, security protocols, and engineering standards. It identifies unhandled exceptions and structural flaws, rejecting the code and returning it to the agent before it ever reaches a human reviewer. Maintaining quality at scale requires fighting AI velocity with AI friction. Automated generation demands automated validation. With code generation commoditized, the value of a human engineer moves from the act of creation to the act of curation. Agents are now highly capable of navigating complex remote terminals and autonomously configuring their own isolated development environments. The physical act of typing syntax is no longer a protective career mode. Software engineering now faces a different constraint: Taste. In this context, taste is the architectural judgment required to know exactly which layer of a system should solve a specific problem. Agents lack this holistic context. They solve problems exactly where they are pointed, even if it creates massive bloat at the wrong architectural layer. Maximizing AI leverage requires building constrained pipelines, but surviving the era of AI requires engineers to defend their system architecture by keeping human taste in the loop.